All right, guys, so we are starting our new unit today. In Unit 5, we're going to be talking all about what are called polynomials. So we're going to start by talking about the kind of introduction to polynomials. What do they look like? What are they? How do we name them? And then we'll talk about adding and subtracting. So to begin with, a couple definitions for us. The first one, a monomial. So a monomial is a number, variable, or a combination of both, a number and variable, which is put together by multiplication. Each monomial is just called a term. So some examples, you could have just a number like the number 5, you could have a variable like x squared, or you could have a combination where you put them together like 7x or 5x squared, or something like that. Now, polynomial is similar. The only difference is in a polynomial, you can have more than one monomial. So they're put together using either addition or subtraction. So you could have something like x plus 2. You could have something like 7x squared plus 3x. You could have something like x to the 5th minus 1x plus 2. As long as it's addition and subtraction, putting those together, it's a polynomial. Now, when we write polynomials, we usually do it in what's called standard form. So standard form of a polynomial is where you write the terms by decreasing exponents. What that means is that you're going to start with your largest exponent and go down to your smallest exponent. So to see an example of this, let's say you had this polynomial right here, 7a minus 6a squared plus 4 plus 2a to the 5th. And we want to write this in standard form. We're going to look for where is our highest exponent. And in this case, the highest exponent is this 5. That means that this entire term, 2a to the 5th, and it was positive, a plus, so we'll leave it as positive, is going to go first. And if you want to go ahead and cross it off to know that you've used it, that would work. The next highest exponent then would be a 2. Again, the entire term, including the minus sign in front, is going to go next. So a minus 6a squared. And again, if you want to cross it off, you're more than welcome to. Next highest exponent would be just a 1. That would be the 7a right here. Notice that there's not a sign in front of it, but it is a positive number, a positive 7. So we're going to make it a plus 7a and write it next. And then finally, we have this plus 4. It's going to go last. And there would be our polynomial in standard form. Now, standard form is useful because it helps us to see what the highest exponent is for our polynomial. It also helps us with naming. So let's do a couple more practice problems with writing polynomials in standard form. For the next one, we've got 8x minus 1 plus 3x squared. So looking for highest exponent, obviously that's going to be this 2. So we're going to put this positive 3x squared term first. Since it's going first, we really don't need this plus sign in front, and we're done with that term. Next highest would be x to the power of 1, so that would be this term right here. Since it doesn't have a sign in front, it's positive 8, so plus 8x would go next. And finally, this minus 1 would go last. All right, one more example here for the next one. We've got our highest exponent right here is a 3. So we're going to put the negative 3x to the 3rd first. Next would be the negative 4x squared. So that's going to stay a minus 4x squared. Next would be x to the 1st power. So that would be this term right here, so plus 5x. And then finally, just numbers by themselves. So the plus 6 would go last. All right. As we continue, we're going to go ahead and name polynomials. So when we name polynomials, we give them both a first and a last name. The first name is by their degree. So when we classify polynomials by their degree, or their largest exponent, we're basically going to look at 0 through 5. We're not going to really talk too much about exponents higher than 5. So if you have a degree of 0, our classification, what we're going to call that is that it's constant. What it looks like when you do that is it's just a number. Like the number 5 would be a constant polynomial. Next, if our degree is 1, that's where we call it a linear function. So this would be where you would have x to the 1st power and then, something else like x plus 2. if the highest exponent is a 2, then we call it quadratic. So if you had something like 7x squared, that would be considered a quadratic. For 3, we call that cubic, so that would be something where you'd have like x cubed plus 2x. That would be considered a cubic polynomial. For the 4th power, that would be what's called quartic, so that would be where you'd have something like x to the 4th minus 1. And finally, for quintic, that's where you've got x to the 5th power, so that would be like x to the 5th minus 3x plus 2 would be considered a quintic polynomial. Now, the second name, the last name, if you want to think about it that way, is by the number of terms. And so when you're talking about number of terms, we're going to talk about 1, 2, and 3 kind of special cases, and then 4 or more we just call polynomials. So if it just has a single term, we've already talked about that. That is a monomial. If it has 2 terms, we're going to call it a binomial. An easy way to remember that, bicycles have 2 wheels, so bi and binomial is going to have 2 terms. You can use that same kind of trick to remember the number 3. So tricycles have 3 wheels, so a polynomial with 3 terms would be considered a trinomial. Okay, so let's do some practice with naming polynomials. So we're going to classify each of the following polynomials by their degree and number of terms. Let's start by writing out the degree for each of our polynomials. So on number 1, y equals x squared plus 4x minus 6. The highest exponent right here is x to the power of 2. Since that's the power of 2, the degree is 2. So our name for our degree is that this is going to be a quadratic. On number 2, our highest exponent this time is a 3. So our name for that, if you look at your chart up above, is that this is going to be called a cubic. Finally, on number 3, be careful. It's not in standard form, so it's not going to be the first exponent. It's actually going to be this second exponent right here, which is the highest. In fact, why don't we do this? Let's go ahead and before we name this, let's go ahead and make sure that this is written in standard form. So in standard form, we're going to start with our highest exponent, which is x to the 5th. So that's going to go first. Next highest exponent is x to the 1st. So that's going to be a positive x to the 1st that goes second. But we actually have 2 constants, 2 numbers. We need to actually combine those together. -1 plus 7 is positive 6. So if there's more than one of a particular term, you're going to have to combine those to be just 1. So now, going back to our degree, notice that the highest exponent is a 5. And so using your table up above, a degree of 5 tells you that this is quintic. All right, now let's go through and name each of these by their number of terms. So number 1, you have 1, 2, 3 terms. So looking at your chart over on the right-hand side now, that is what's called a trinomial. On number 2, you have 1, 2 terms. So again, using the chart on the right, that is a binomial. And finally, on number 3, looking at your simplified or your standard form equation, you've got 1, 2, 3 terms because you put together the -1 and 7. So this would also be a trinomial. So if you wanted to say them together, number 1 would be a quadratic trinomial, number 2 would be a cubic binomial, and number 3 would be a quintic trinomial. Now, in this section, we're also going to look at a couple of operations. We're going to look at how you can add polynomials together and how you can subtract polynomials. Really, all it comes down to is being able to combine like terms, which is something you've seen since middle school. So, adding polynomials. Again, when adding polynomials, like I just mentioned, we combine our like terms. Now, to make it easy, what we're going to do is start with our highest exponent, or degree, and go down to our lowest. And the reason we do that is that our answer is going to be in standard form every time we work it that way, which is going to make classifying a lot easier. So let's take a look at this first example. We've got in parentheses 4x squared plus 6x plus 7, plus in parentheses 2x squared minus 9x plus 1. So we're going to look for where's our highest exponent. And our highest exponent in this case is x to the power of 2. I'm going to put a circle around each of those. And then we're just going to combine those together. We're going to take 4 plus 2, add the numbers in front, is 6x to the power of 2. And again, we can just kind of cross them off when we're done. Next highest exponent would be just x to the power of 1. We've got 2 of those. We've got positive 6 and negative 9. 6 minus 9 is a negative 3, so that's going to be a minus 3x. And we can cross those off if we're done. Finally, we've got 7 and 1. 7 plus 1 is 8. So here is our polynomial in standard form. So to name it, we need 2 different parts. We've got our degree, which is 2, so that's going to make this a quadratic. We also have 1, 2, 3 terms, so this is going to be a trinomial. Okay, let's take a look at a couple more examples. So the next example, once again, we're going to look for highest exponent, which is x to the power of 2 in this case. So we've got 6 plus 2 is 8x to the power of 2's. Our next highest exponent is x to the power of 1. There's only one of those, so we're just going to copy it down as it is. At this point, we're ready to look for just our numbers by themselves. We've got a 7 and a minus 4. 7 minus 4 is 3. And now we are ready. We are in standard form, ready to name it. So once again, our degree in this case is quadratic. And in fact, if you notice, it also has 3 terms just like the previous example. So this is also a quadratic trinomial. Okay, let's take a look at one last example of addition, and then we can talk about subtraction. So in our next example, our highest exponent this time is actually powers of 3. So we've got 9w to the power of 3 and 7w to the power of 3. If we add those together, that becomes 16w to the power of 3. Our next highest exponent is powers of 2. There's only one of those, so we will just copy it down as it is, as a positive or plus 8w squared. Next highest is just w by itself, so that would be 3w. Again, nothing to combine it with. And then finally, numbers by themselves, once again, nothing to combine them with. So now, naming this one, our highest exponent, highest degree, is a 3, so that's going to make this cubic. And this time we have 1, 2, 3, 4 terms, so we're going to call this a cubic polynomial. Now, as we take a look at subtraction, we're going to keep a lot of the same ideas as addition. The one difference being that we're going to distribute the minus sign. In other words, we're going to change the sign of all of the numbers and terms in the second parentheses. And then in step 2, just like we did for addition, we're just going to combine all of our like terms. So let's take a look at an example of how subtraction works, really the only difference being the first step. And that first step is we're going to take this minus sign and apply it to all 3 terms in the second parentheses. So the positive x cubed is now a minus x cubed. Our minus 8x squared is now a plus 8x squared. And our plus 11 is now a minus 11. Notice that there's nothing in front of our first parentheses, so we're just going to copy down each of those terms as they are. We're not going to change anything for that first parentheses. Let me make sure I've got this written correctly. X to the third, there we go. Now it's just like addition. We're going to find our like terms. So our highest are x to the powers of 3. 2 minus 1 is just positive 1x to the power of 3. And then cross them off. So again, once you've done that first step, it's just like addition. Next highest exponents are powers of 2. So 5 plus 8 is 13x to the power of 2. Next highest exponent is just x by itself. So a minus 3x. It's going to stay as is. And then our minus 11 is going to go last. And here is our polynomial. Now, once again, we're going to continue to practice classifying each of these. In this case, our degree, our highest exponent is a 3. So this is cubic. It also has 4 terms. So it's going to be a cubic polynomial. Okay, let's take a look at just 2 more examples and we will be done with this lesson. So again, anytime you've got subtraction, make sure that you are starting by distributing that minus sign and changing each of the signs in your second parentheses. Not just the first, so minus 5x cubed, but also the 2x and the minus 2 need to be switched as well. Now again, nothing in front of our first parentheses, so that's just going to stay as is. All right, once we've done that, it's really just an addition problem. So look for your highest exponent, which is x to the power of 3. And 2 minus 5 is negative 3x to the power of 3. Our next highest exponent is x to the power of 2. Nothing to combine it with, so we will just copy it down. Same thing with our minus 2x. That's our only just plain x term, our only linear term. And then we'll be able to combine minus 6 plus 2 to be a minus 4. And we've got our polynomial. Just like the last 2 examples, you can see the degree is 3, so this is cubic. And you can see that there's 4 terms, so this is going to be a polynomial. All right, one last example, guys, and we will be done with the lesson today. So again, our last example, we've still got subtraction, so make sure that we are changing the sign of both terms inside the second parentheses. Everything that's in the first parentheses, we're just going to copy down as it was. All right, so looking for our highest degree, that would have to be d to the power of 3. If we take 30 minus 1, that's 29 d to the power of 3. Next up is d to the power of 2. We've got negative 29, and negative 2 is going to be negative 31d squared. Finally, we just have d by itself right here, so that's going to be minus 3d. And in this case, we don't have any numbers just by themselves, so no constant term. So then that's going to be it for our final answer. Now, just like our last few examples, it does have d to the power of 3, so this is still cubic. However, this one only has 3 terms, so this is an example of a cubic trinomial. All right, so guys, today we were able to see our first 2 operations. We were able to see addition and subtraction. In the next video, we'll take a look at the other 2 operations, so we'll look at how you can multiply and divide. Until then, have a great rest of your day.